This is a little bit of vocab or discussion of kind of the base units of measuring some things here. The mass of the moon. Well, the base unit for the SI base unit is grams. But talking about something as massive as the moon, you'd probably use something like kilograms. I'm just going to abbreviate with kg. Or maybe if there's a metric ton, like 1,000 kilograms, because it's so massive. A paper clip, you would measure in grams. Kilogram, you measure the moon. From DFW to Oklahoma City, that would probably measure, the base unit for that is meters. That is the SI base unit, meters. You probably wouldn't say the meters of DFW, Dallas, Fort Worth to Oklahoma City Airport. You'd probably think about it in kilometers. Remember, we're trying to think SI or metric. We're not trying to think miles. But it's also the same relationship we made there. You would measure distances between cities in miles. You wouldn't measure it in feet or yards. The velocity, when it's like the speed of light or velocity of sound, we would do that. Now that is a ratio of meters divided by seconds. So those are the SI units right there, the base units. Meters divided by seconds. If you were measuring the velocity of, say, a snail, something that moves very, very, very slow, you might do something like centimeters per second. Maybe something like that. Or maybe if it's incredibly, incredibly slow, you might do centimeters per minute. Okay? But nevertheless, a distance divided by a time. Now this little funny unit here, this is meant to, it doesn't say the word pair as if you have a pair of socks. This is meant to be the lowercase Greek r pronounced rho. And this stands, in chemical speak, this stands for density. So I would say this, if I were to say this symbol over the phone, I would say density of, and then whatever's written in subscript here, here we're talking about air. Okay? So the density of air, that's a mass divided by a volume. So that could simply be grams per milliliter. Now, consider the density of air, how least dense or how diffuse air is. Grams per milliliter, you might have a grams so small of air that the number is just really a bunch of zeros behind a decimal point. So you might say grams per cubic meter, a meter to the third power right here, to try to get this number like in a tangible form right here, because air is so diffuse or not dense. This down here, in contrast, this is, I would say this over the phone, density of water, H2O. And I should say I'm thinking about liquid water in this right here. Now, grams per milliliter is an appropriate density unit for this discussion here. And if you recall, it's, we can say approximately that it's the density of liquid water at room temperature, standard pressure, is 1 gram per milliliter at sea level right there. Thank you.